All right, we're going to do the notes for 12.3, which is surface areas of pyramids and cones. So a pyramid is a 3D figure in which the base is connected to faces that meet at a common point. Okay, your base is going to be, oops, I need my pen. Your base is going to be a regular polygon. All right, and then all the faces are triangles. So they are triangular faces, and they meet at a common point called the vertex. Okay, so when you name a pyramid, you are going to use the base to create the name. So the base of this pyramid has 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagonal pyramid. This next one, the base has 5 sides. 1, 2, 3, 4, 5. So this would be a pentagonal pyramid. And this last one, the base is a rectangle. So this would be a rectangular pyramid. All right, let's talk about lateral area of a pyramid and the net. Let's actually talk about the net first. So again, the net is a 2D version of a 3D shape. So if we look at a 3D pyramid, so this is a pentagonal pyramid, the bottom is pentagon. If we make the net, we take our triangular faces and we fold them flat. So we take our faces and we fold them down so they're flat on the surface, and we end up getting a star, some sort of star. And the number of points on the star depends on the base. So this base is a pentagon, so we get 5 points on our star. The triangles, these are your faces, and they all will fold back up and meet at a vertex at the top. And then here's your single base. Your lateral area is the sum of the areas of all of these triangles. Okay, so the area of a triangle is 1/2 times the base times the height. Okay, if you look at all these triangles, this base is congruent to this base, which is congruent to this base, which is congruent to this base, which is congruent to this base. Same with the heights. The heights are marked by this cursive L here, and they all have the exact same height because they all the triangles reach up to the same peak. Okay? So, same height, same height, same height, same height, same height. All right, so what happens here is you are going to find 1/2 times the base times the height, and then 1/2 times the base times the height. You're just going to keep doing that. If you add all those areas up, you're going to get a nice area or a nice formula for the area of your lateral area. And that formula is up here. It's the sum of the areas of the triangular faces, and it's 1/2 times the perimeter of your base, which is the sum of all of the bases of your triangles, times this cursive L, which is the height of all your triangles. And we call that the slant height. So if you look at a pyramid, it's the height on the triangle. So when the pyramid's together, it's a slanted height from the base to the vertex. Okay? So that's the formula for lateral area. Let's practice. Find the lateral area of the pyramid. So for lateral area, it's 1/2 times the perimeter times the, not the height, the slant height. So if we look at this, we have a slant height of 11. So it's 1/2 times the perimeter times 11. We don't have the perimeter because we don't have side lengths. But if you look at this right triangle created here, this unknown here, x, if I were to draw the base of this triangle kind of straight on, it's a square base. Okay? Here's the center of the base as it is marked here in black. Okay? The bottom of this triangle, we'll call that value x there. is this length here, which is half of the side length. So our side length here is going to be 2x. Okay, x plus x, which is 2x. So let's take our right triangle and use the Pythagorean theorem to find x. So we're going to do 9 squared plus x squared equals 11 squared. So 81 plus x squared equals 121. So x squared equals 40. So x equals about 6.32. All right, so now we know x. The side length is double of that. So our side lengths are all 12.64. So our perimeter is 12.64 added to itself 4 times, or we could do 12.64 times 4. And if we do that, we get a perimeter of 50.56. So our lateral area is 1/2 times 50.56 times 11. And we get an area, and it says round to the nearest tenth, so a lateral area of 278.1 inches squared. All right, I want you to pause here and try this next one on your own. All right, so if we look at this, the lateral area, again, is 1/2 times the perimeter times the slant height. The perimeter is 8 times 5, which is 40, right? Because all the sides of this pentagon are congruent. So 8 times the 5 sides, we get a perimeter of 40. And then we're given the slant length, it's 10.6. So we plug that in, and we get that the lateral area is 212 meters squared. Go into the back now. Total surface area. You're going to take your lateral area and add it to the area of your base. Okay? So for these next problems, these are the exact problems we just had on the last page. Right? We already know the lateral area here. It was 278.1 inches squared. So we need to find the area of the base. Remember, the side length of the base was 12.64. So our base is a square, so it's base times height. Our base and our height are the same, so it's 12.64 times 12.64. So if I do that, I get a base of 159.77 for the area there of our base. So the surface area is the lateral area plus the base area. So it's 278.1 plus 159.77. If we add that up, we get a final surface area of 437.9, and then our units would be inches squared. All right, so I want you to pause here and do this next one on your own. As a reminder, that was our lateral area from the last page. All right, so we find the area of the base then. The base is a regular pentagon, so we use the area is 1/2 times the apothem times the side length times the number of sides, which all that information is given to us. We simplify to get a base of 110. Surface area is lateral area plus base area. Add them together. Surface area is 322 meters squared. All right, find the lateral and total surface area of the given pyramid. Round your final answer to the nearest tenth. All right, so we need to find lateral area, and then we also need to find the base to find the surface area. So our lateral area is 1/2 times the perimeter times the slant height. So 1/2 times the perimeter of our base, so we have an image of our base, half of this side length is 2.5. So this entire side length of our regular hexagon is 5. So our perimeter is 5 times 6 because there's 6 sides. 5 times 6 is 30. So our perimeter is 30. Our slant length is the 8 centimeters given there. All right, 1/2 times 8 is 4, so I'll do 4 times 30, which is 120. So our lateral area is 120 centimeters squared. Okay, so that's one thing we're asked to find. And then we're also asked to find the base area. So the base is a regular hexagon, so it's 1/2 times the apothem times the side length times the number of sides. We don't know the apothem. We know the side length is 5, and we know that the number of sides is 6. And so that's the formula we're dealing with. Okay, if I do 5 times 6, I get 30, times 1/2 is 15. So really, we're going to be doing 15 times A, which A will be our apothem. To find our apothem, we have a right triangle here. You guys see that? This right triangle. We got 2.5. We've got our apothem A, and that's a 30-degree angle. So we could use tangent to find A, or it's a 30, 60, 90 triangle. So the short leg is opposite of the 30, so 2.5. The long leg is the short leg times square root of 3. So the apothem is the short leg times the square root of 3. So our base is 15 times 2.5 square root 3. If I do 15 times 2.5, I get 37.5 times the square root of 3. And I'm just going to leave the rounding for the end, so my surface area is as close as possible. So the surface area, let's do this in blue so it sticks out, is the lateral area plus the base area. So 120 plus 37.5 square root 3. So if I put that in my calculator, 120 plus 37.5 square root 3, I get a surface area of 184.95 centimeters squared. Now it says to round to the nearest tenth. So to the nearest tenth, the 5 makes the 9 round up, which it can't, so then the 4 needs to round up. So the surface area to the nearest tenth is 185.0 centimeters squared. All right, let's talk cones. So a cone is another type of 3D shape. It has a circular base, and it doesn't have faces, okay? Instead, this part here narrows up to a vertex smoothly, okay? Because the circle has no edges. The lateral area is pi times the radius times the slant height. And then the total surface area is your lateral area plus the base area, okay? So it ends up looking like this, because your lateral area is this formula, your base of a circle is that area, and you could simplify it to this, but I'm not going to make you do that necessarily. All right, so let's get some practice. Find the lateral area of the given cylinders, and then below it says to find the total surface area. So let's do both, and then I'll have you do the second one on your own. So let's find the lateral area to start. So the lateral area of a cone is pi RL. Pi RL. So R is the radius, and the radius of this base is 13, half of 26. So it's pi times 13 times, and then L is the slant length, which is 39. So in terms of pi, this lateral area, if I do 13 times 39, I get 507. So it's 507 pi inches squared. It does tell us to round to the nearest tenth, so I have to do 507 times pi, and I get a lateral area of 1,592.8 inches squared. So there's my lateral area. Now it wants me to find the total surface area. So the surface area is the lateral area plus the area of the base. For my surface area, I'm going to use my non-rounded lateral area. So my surface area is exact as possible. So I'm going to do for my lateral area 507 pi plus, and now I need to find my base. So my base is a circle, so it's pi r squared. The radius was 13. 13 squared is 169, so the base is 169 pi. And I will save that rounding for later as well. So if I do 507 plus 169, in terms of pi, my surface area is 676 pi inches squared. But again, it's telling us to round to the nearest tenth, so I do 676 times pi and round to the nearest tenth, so I get 2,123.7 inches squared. And that would be my surface area of that cone. All right, I want you to pause here and try this second one on your own. All right, you will need to find your slant height here. So to do your slant height for your lateral area, you'll want to use the Pythagorean theorem because you have a right triangle here. So you get that your slant height is 20. So you plug that into your formula and you get, in terms of pi, the lateral area is 240 pi, but it wants it to the nearest tenth, so our lateral area is 754.0 feet squared. Then, to find the total surface area, I would recommend using your non-rounded lateral area, the 240 pi, and then add the area of the base circle. Well, the base of the circle has a radius of 12, so r squared times pi, so 144 pi. So in terms of pi, the surface area is 384 pi feet squared. But it says round to the nearest tenth, so we actually have to put that in our calculator and round, and we get a surface area of 1,206.4 feet squared. All right, a couple more problems. A waffle cone is 5.5 inches tall with a diameter of the base that is 2.5 inches. Find the lateral area of the cone. Okay, so a cone, the top or the base would be there, right? If it's a waffle cone. The height, so from the center of the circle to the vertex, is 5.5 inches. And then the diameter is 2.5 inches. We need to find the lateral area of the cone. So the lateral area is pi r l. The radius of our base circle is half of 2.5, so the radius is 1.25, but we do need to find the slant length, which is this length here. Well, the height and the diameter are perpendicular to each other because the height is perpendicular to the base, so we can make a right triangle. The height is 5.5, that diameter there was 1.2, the radius is 1.25 there, it's this part here, and we'll find our slant length. So we are using the Pythagorean theorem. So 1.25 squared plus 5.5 squared equals L squared. If I plug this whole thing into my calculator, I'll get 31.8125 equals L squared, and then take the square root of both sides, you get about 5.64 equals L. So that's what we'll put in for L into our formula. And if we put that whole thing in our calculator, we'll get 22.1, or 22.2 inches squared for our lateral area. All right, a cone has a surface area of 36 pi square inches and a base radius of 4. What is the slant height of the cone? So we are trying to find the slant height. We're told the surface area. The formula for surface area is lateral area plus base. But if we're trying to find this variable, we need to put our surface area into terms using that variable. So lateral area is pi r times the slant height. Base area is pi r squared. All right, let's plug in what we know. We know that the base radius is 4. So all of our r's are 4. So pi times 4 times L plus pi times 4 squared. Okay, you got a lot of options now to solve for L. Our surface area, hold up, we know the surface area. It's 36 pi. So let's write that. Okay. Well, like I said, there's a lot of different ways of doing this. First thing I see is I'm going to change the 4 squared to 16. So this is 16 pi. And then I'm going to subtract 16 pi from both sides. 36 pi minus 16 pi is 20 pi. So I have 20 pi equals, I'm going to change that pi times 4L to 4 pi L. And then if I divide both sides by 4 pi, the pi's cancel. The 4 cancels here, so I'm left with L. And then 20 divided by 4 is 5. So the slant height of the cone would be 5 inches. All right, one last thing. What is the difference between pyramids and prisms? Okay, 2 main differences here. One, the prism has 2 bases. A pyramid has 1 base. Second thing, prism faces are rectangular. Pyramid faces are triangular. Okay, those would be your 2 main differences there. And that completes the notes for 12.3.